Okay, we're going to run through another example here. This one's, again, does not have a 0 on one side. So the first thing we're going to need to do is get that 0. Again, I'm going to get that on the right side by subtracting 30x from both sides. When I do that again, there are no common or like terms on the left side, so I have to keep them all separate. 4x cubed minus 14x squared minus 30x is equal to 0. Those dropped out. Now we have to factor the remaining polynomial. This polynomial does contain a greatest common factor. In fact, there's a number and a variable involved here, right? The number 2, because all of those are even, and we have an x in every term, so I can pull an x out. So I'll pull out a 2x, and I'll be left with a 2x squared minus 7x minus 15 when I divide everything by 2x. Okay, so this is now a trinomial. Remember, trinomials, we factor those either using the perfect square trinomial formula or the modified AC method. Here, the first and last terms are not perfect squares, so I know it won't fit the perfect square trinomial formulas. The leading coefficient is not 1, so I have to go through the longer modified AC method, which is good practice to go ahead and do that. So remember, with the modified AC method, we're going to start with 2 sets of parentheses and building the structure of the equation. The 2x goes in the first 2 slots there. Remember, we have to figure out what AC is. Take this off to the side. AC is equal to negative 30. And we're looking for factors of negative 30 that add up to negative 7. Okay, well, when I think about negative 30, or factors of 30 are 1, 30, 2 and 15, 3 and 10. 3 and 10 is obviously the correct one. There's also 5 and 6 in there, but I won't bother with that because as long as the negative is on the 10, right, we have to have one negative to get the product to be negative, and it has to be the bigger one to get the sum negative. So 3 and negative 10 will be the right combination. I'm going to put those in, plus 3, minus 10. But remember, when we factor using modified AC, I do have to divide out any common factors here, which in this second set of parentheses, there's an extra 2. Excuse me. This one does not have a common factor, so we're okay there. So when I pull out that 2, what I really have is 2x times the quantity 2x plus 3 times the quantity x minus 5. Okay. These 3 factors, when multiplied together, do equal the original polynomial that we tried to factor a moment ago. And so I can set each of these factors now equal to 0. Interestingly, I actually have 3 factors. I'm going to set each of them equal to 0. So 2x equals 0, 2x plus 3 is equal to 0, and x minus 5 is equal to 0, all 3 of them. Okay. Then I go through and solve the resulting equations. Well, the first one, I could just divide out the 2, but it's not going to change anything. 0 is the number, or the solution there. Here I need to subtract a 3. I get 2x equals negative 3, then divide by 2, and x is negative 3 halves. Fraction form is fine. If you want negative 1.5, that would be fine as well. Here I add the 5, and I get x equals 5. So I actually end up with 3 different solutions to this original equation. And so my solution set is going to be the set containing 0, negative 3 halves, and 5. The order doesn't matter when we're dealing with a set. Sometimes it's nice to put them in numerical order, so I might switch the negative 3 halves with the 0, but it doesn't really matter. Okay. So this original equation has 3 solutions, and of course you could check those 3 solutions. If I check the 0, well, the first term zeroes out, second term zeroes out, and the third term all zero out when you put a 0 in there. So you get 0 equals 0. So that works out nicely. I'm going to save the fraction just because the arithmetic's a little tricky here. I'm just doing this as an example, but we could try the 5. If I did 5 cubed, that's 125 times 4 is 500. So this would be 500 on this term if I put the 5 in. Is that right? Yeah, 500. Then if I put the 5 in here, 5 squared is 25. What's 25 times 14? 25 times 14 is 250, and another 100, 350? 350, I believe. And if so I'd be subtracting those, so the difference is 150. And if I put the 5 in on the right side, 30 times 5 is 150. And so I should have the same thing, which we do. So 150 on each side. I could do that again with the negative 3/2. I'll spare the arithmetic. It should work out just fine. Okay. All right, let me get rid of those. Okay. So anyway, that's how you would check the solutions. It does work out. And of course, there are 3 answers to this one.